Hi, let's get started with the Introduction to MapReduce Framework lesson. In this lesson, you will learn about the MapReduce Framework, identify its benefits and how it works, and finally you run and monitor a word count MapReduce job. The MapReduce Framework integrates with HDFS and provides the same benefits for parallel data processing. It parallelizes and distributes computations to where the data is stored. Replication increases availability and increases opportunities for data locality. It is more efficient to move the computation closer to where the data is located rather than moving the data to where the application is running. The framework schedules and monitors tasks, hides complex distributed computing tasks from the developer, and enables developers to focus on writing the map and reduce functions. Let's go over the process of how MapReduce works. A MapReduce job is a unit of work requested by a client. The job consists of input data, which is usually stored in HDFS, and a MapReduce program, which is created by the developer. In this example, we have two HDFS input files. Hadoop divides the input files into fixed-size pieces or chunks named input splits. The input split is usually the same size as an HDFS block, which is typically 128 megabytes, and it contains many records in the form of key-value pairs. Hadoop creates one map task or mapper for each input split. It runs the user-defined map function on each key-value record in the input split and generates new key-value pairs. Hadoop tries to run the MapReduce tasks on the same worker nodes where the data is located. The reducer task starts with the shuffle and sort step. It downloads the group key-value pairs to the local machine where the reducer is running. The individual key-value pairs are sorted by key into a larger data list. The data list groups the equivalent keys together so that their values can be iterated easily in the reducer task. The reducer takes the group key-value paired data as input and runs a reducer function on each one of them. Here, the data can be aggregated and filtered to produce new key-value pairs. And finally, the output of the reduce phase is the union of all records. Let's go over a simple MapReduce word count example. The MapReduce process is started. The input text file is divided into key-value pairs with several records in each input split. For example, the first input split contains the words hello, world, bye, and world. Hadoop creates one map task or mapper for each input split. The mapper gets the key-value pairs as input. The key in this case is the offset into the file, which is not useful in this example, and the value will be a word such as hello, world, bye, and world. The mapper task is started on the node that contains the data that is needed in the processing. The goal of the mapper function is to parse the sentence and emit each word as a key with a numeric value 1. Each mapper emits a word with the number 1 every time a word is found. For the first mapper, the output is the key-value pairs hello, 1, world 1, bye 1, and world 1. Each mapper finishes the initial processing and sends the output to the shuffle and sort phase. In this phase, the individual key-value pairs are sorted by key into a larger data list. The data list groups the equivalent keys together so their values can be iterated easily in the reducer task. For example, all key-value pairs from the mappers that contained hello 1 are now grouped as hello 1 1 1. Next, the shuffle and sort copies the local sorted data as input to the reducers. The reducer receives each key, that is the word, and a value 1, and simply adds up or aggregates the ones to compute the word count. In other words, the reducer combines the mapper's output into a total. For example, the reducer combines hello 1 1 1 key-value pair from the previous step into hello 3. Finally, the output of the reduce phase is the union of all records that are produced by the reducers, and the result is written to the output file. When you're running a MapReduce job, Hadoop does its best to run the map task on a node that contains the HDFS block that is required by the map task as shown in the first example, where the data block and the mapper are located on the same worker node. This is called data locality optimization. Sometimes, all three nodes hosting the HDFS block replicas for a map task's input split are running other map tasks. Therefore, the job scheduler locates a free map slot on a node in the same rack as one of the HDFS blocks as shown in the second example. If both situations are not possible, Hadoop uses an off-rack node in the cluster, which results in an inter-rack network transfer as shown in the third example. In Yarn, mapper and reducer slots are replaced with containers. This is covered in the Yarn lesson. In the Oracle Big Data Lite VM, click the terminal icon on the toolbar to display a terminal window. For the remainder of this lesson, we will go over the classic MapReduce word count example, which counts the number of word occurrences in two text files in HDFS. We will use the Oracle Big Data Lite VM for this demo. On the screen, we navigated to the Home, Oracle, Exercises, Word Count directory, and then listed the contents of this directory. If you are using the Big Data Lite VM for this demo, you'll need to change the privileges on the .sh files to read, write, and execute as shown on the screen before you can run any of the highlighted scripts. The WordCount.java program finds out the number of occurrences of each word in file 01 and file 02. The code for the mapper function is on lines 14 through 26. The code for the reducer function is on lines 28 through 37. You can use the cheat.sh script to run the entire word count demo. On the screen, a summary of the tasks performed by this script is shown. To run the script, enter /cheat.sh at the command line. After you successfully run the cheat script, you can perform the required cleanup by running the cleanup script. This is required if you plan on using the cheat script again to rerun the word count demo. On the next few screens, we will run individual scripts that you can find in the Exercises word count directory, which will perform the same tasks that are found in the cheat script, so that we can provide some explanation as to what the commands do. You can run the compile script to compile the WordCount.java program. The javac command compiles the WordCount.java program and it creates a compile.java class file. The -cp or class path option specifies where to find the user files. The -d or directory option specifies where to place the generated class files, WordCount classes directory in this example. The create.jar.sh script creates the jar file. The jar command packages the application into a single archive file and places it in the current directory. The C options create a jar file. The V option lists the name of each file as it's added to the jar file. The F option specifies that the output should go to the new jar file rather than to stdout. The -c word count classes /period specifies that everything in the word count classes directory should be archived. We will count the number of occurrences of each word in file 01 and file 02 text files using the WordCount.java program. The two files contain customers' feedback on a fictitious car insurance company. The customer's comments will be used as the basis for the sentiment analysis. The copy file script copies files 01 and 02 from the local file system directory to the HDFS directory. First, we will need to create the word count and input HDFS directories, which will contain the two input files. After we create the directories, we run the copy files script. The run word count script contains the Hadoop jar command that submits the MapReduce program. The command contains the name of the jar file that contains the map and reduce user-defined code and the path for the input and output HDFS directories. Next, we execute the run word count script to perform the word count. Informational text from the Hadoop infrastructure is displayed on the screen to help you track the status of the job. When the job is completed, the command prompt is redisplayed. The highlighted information shows the MapReduce Job ID that you'll need if you want to kill the job while it's running. You can track the MapReduce Job by using URL provided. Click the browser icon on the Big Data Lite VM toolbar. Click the Hadoop drop-down list and then select Yarn Applications. The Yarn Web UI All Applications page is displayed. This page shows the jobs that are managed by Yarn and their status. In this example, there are a couple of MapReduce jobs which correspond to the word count programs that we ran twice. The status of both jobs is succeeded. Yarn is used to manage resources on a Hadoop cluster. To access the Job History Web UI on the Big Data Lite VM, click the Hadoop drop-down list and then select Job History. The Job History server archives jobs and metrics and can be accessed through the Job History Web UI or HUE. You can click a Job's ID URL in the Job ID column to display the job's details. Let's click the first job ID in the list. Note that this MapReduce job has two mappers and one reducer. You can click the map or reduce links for the job to display additional information. Let's click the map link. The map tasks for the selected MapReduce job are displayed. Let's click Go Back to the previous page. Click the Reduce link to display information about the reduced task. The Reduce Task page shows a single reducer for the selected MapReduce job. Finally, let's take a look at the contents of the word count output HDFS directory. After running the MapReduce job, this directory contains two files. _success, which is a simple flag that MapReduce generates to indicate that the job ran successfully. The part R0 file contains the output of the MapReduce word count program. The output file name usually contains either an M or an R as part of the name, depending on whether the job was a mapper or reducer. It also contains a 5-digit sequential numeric number starting with 0. Let's take a look at the content of the part R0 file using the Hadoop fscat command. The output shows some of the customer's comments that can be used for sentiment analysis such as best, disappointed, expensive, terrible, worst, and so on. In this lesson, you'll learn the benefits of MapReduce and how to run and monitor a MapReduce job. Thanks for watching. Learn more at docs.oracle.com/en/bigdata.